Hey everyone, my name is Jeremy Fairbank. I'm El Papapoyo on Twitter, and this is Advanced Cypress Testing. Briefly about me, I work for TestDouble as a remote software developer and consultant. We believe that software is broken and we're here to fix it. So our mission is to improve how the world builds software. And we like to do that by not only working alongside your team to help you get stuff done, but more importantly to help your team improve and grow. So if you'd like to have our team of consultants work alongside your team, or if you'd like to join an awesome team of consultants, please check us out at testdouble.com. I'm also the author of Programming Elm from the Pragmatic Programmers. Elm is a functional programming language that compiles to JavaScript, and it comes with a built-in framework for building front-end apps. And the book takes you from knowing nothing to learning its syntax, to building simple apps, to building complex single-page apps, as well as doing testing, benchmarking performance, and a lot more. So if you're interested in learning more, you can pick up a copy at programming-elm.com. So today I want to talk about several testing anti-patterns that I've seen in my time using Cypress. And this won't be an exhaustive list, but I at least want to identify some big ones that can lead to brittle and unmaintainable tests. Debugging and maintaining these tests will really hamper your productivity. So we're going to look at some solutions to help alleviate these problems so you can build a more robust test suite. Now before we dive in, I want to highlight some assumptions about the kind of Cypress test suite that I'm talking about. So these are end-to-end tests. So we're going to drive the UI as it's interacting with the API all the way through the back end. And so that means we're going to be using a real application API here. We're not going to be mocking that out. However, we will be using a test data set, so we still have some control over the data that we expect this API to return to our app. Now for context, the application we're going to be testing is a single-page React app that lets you search, rate, and review some of the top jazz albums from the past century. You can run the app and the test by visiting the GitHub repo link that's provided here. So let's get started. So the first set of anti-patterns, it's a two-parter that I like to call Selector Syndrome. So the first anti-pattern comes from how we select elements from the DOM in our test. And the second anti-pattern comes from the noise and kind of duplication of selectors in our tests, which we'll see a little bit later. So let's look at a few tests to see what I'm talking about and what problems they may cause. So in this test file, we're testing the home page, which lists all the jazz albums on the application. So first we're going to import some test albums from this JSON file that the server itself is also using when running a test server. So since it's shared, I'm importing it instead of using Cypress's fixture functionality, since both the API and the test need it. So this first test, it's mostly straightforward test to ensure that the albums that I expect to see are actually displayed on the page. So walking through this, we're going to first grab different elements based on different kinds of selectors. Here we use the class album list item to get all the album elements to verify the length matches. And inside this for each, we're going to loop over that test array of albums that we got from the JSON. And then we're going to grab the album list item by class again and get its h2 tag. And that contains the album title. And we're going to verify we grab it by that album title. And then, once we verify that and we got that element, we're going to go back up to the parent, the class album list item, get its container, and verify it exists, and then find the h3 tag to verify that it contains the album artist that we expect. So lots of selectors we're using here so far. In this next test, we're going to verify that we can sort the albums on this home page. So we're going to look for this class filter selection, it's some kind of container, and we want to get the one that contains the text sort by. Once we have that, we're going to look for within that container the select tag so that we can select to sort by title of these albums. And we do something similar down here in the rest of the test where we're going to find that select tag and we're going to select to sort by artist and sort by the default sort order. Now we have the helper function up here to reduce some duplication for our assertions, albums sorted like, and it's going to accept an array of albums that we have pre-sorted from our test albums, and this is the order of albums we expect to see in the DOM. So we're going to loop over those with a for each, and then we're going to again use that class album list item to find all the albums, and then we're going to filter it down with the equal call here to say it needs to match this index in the album list. And then we're going to find the h2 tag to verify that it contains the title for this expected album at that index. And then in our final test here, we're going to verify that we can search for artists and filter down the list of albums. So we're going to use the side.contains here. We're going to look for that filter selection again, and we're going to look for a container that has search artist text. And then within that, we're going to find the input element so that we can type in a search query. Once we've done that, we're going to grab by class again all the album list items and verify that it's only the ones we've filtered down to. And then we're going to find the h2 tag and verify it contains the album titles we expect. And then we're going to go back up, because we've changed the scope to the h2, we're going to go back up to the container, the album list item class again, find the h3 tag, and verify that it contains that artist. So there's a lot going on in these seemingly simple tests. We're depending a lot on class names and tag names for selections. But what happens if we need to change up the markup, or we need to move or rename CSS classes? It can be a problem here where we depend on those types of selectors that could more readily change based on business needs or style needs. So for example, here's the album list component from our React app. It's a link with an image, a rating icon, an h2 tag, and h3 tag for the title and artist. So let's say we want to simplify the class name and the CSS associated with it, so we rename the class to album. And let's say we also want to change the h2 and h3 tags to h3 and h4. What's going to happen? Well, our tests are going to fail, but not for the right reasons. The functionality and output of the component hasn't changed, just the style and some markup. But this shouldn't cause our tests to fail. So now we're going to have to investigate to determine why these tests are failing, which eats up our development time. And this can erode our confidence in our test suite if this happens often. It can also make us apprehensive about ever changing our markup. So instead, let's revisit that component to see how we can create better selectors. So we can decouple our tests from the markup by providing hooks specifically for selecting elements for testing. Here we add a data test attribute with the value album list item. Data attributes are great for adding custom attributes that are still valid HTML. And for our header tags, we can add data test attributes of title and artist. And with these hooks, it doesn't matter if we change the tag name or change the CSS classes, because the data test attributes are going to remain the same. So back in our test, we can change our selectors to use the data test attributes. So we use this syntax here for selecting based on HTML attributes. We have this key value pair of the attribute and its value in quotation marks, and then we wrap all that in square brackets. So we select the albums with data test set to album list item. In the for each, we select on the data test title containing the album title. And then we can grab the album list item parent from that to go back up in scope and verify that exists, so that then finally we can look for the data test artists within that container and then verify that those artists are what we expect. So we could even make it simpler and not depend on maybe finding the artist element, and we could maybe really only care about that the artists show up in this album container. So we can find the data test album list item, and we can just say it contains this title, and then also verify it contains the artist. There's a lot less here to parse, and it's a lot cleaner and simpler test. So whatever we need to do to really make these tests more robust. We can make a similar modification to the select element for sorting albums. We can add a data test attribute with a sort by value. Then in our test, the selection becomes simpler. We get the select element directly by the data test attribute instead of looking for a container with this text sort by and then trying to find the select tag. And assuming we have a data test attribute that we've added to the search input, we can also find it via a data test attribute of search artists. And again, we get the albums by their data test attribute to verify that after we've filtered by this search, we get what we expect. So now we have a solid way of selecting elements we want to test without worrying about markup or CSS. The data test attributes shouldn't need to change much, if at all, and if we do need to rename them or change them, then we'll know the test will need updated because we're changing something specifically for test. And instead of changing markup and then having failing tests that we need to investigate to see if they're really broken or not. So returning back to this first test, I want to look at a second problem with the selector syndrome. You may have noticed that our test became a little noisier with all these data test selectors. They require more syntax and more typing compared to the class and tag selectors. We also may need to duplicate some selectors like album list item because we need to select it multiple times. So we could possibly misspell or miss a character, which could lead to some frustrating debugging. The noisiness of these selectors are less declarative and provide less semantic meaning about how a user interacts with our app too. So we can solve this problem with page objects. Now, page objects can be controversial in the Cypress community, but I think with the right approach, they can offer a great solution without being too cumbersome. So we're going to use what I would call simple page objects. They're simply functions that wrap over our selectors. So I create a new home page object in the Cypress support pages directory that I've created. And I export functions for different data test attributes that we were using earlier. So here we create an albums function, and it's going to wrap over sci.get with data test set to album list item. And we're going to get all the albums essentially. We also have an album function that accepts a title argument, and it returns the album list item that contains that specific title. So let's first see how these two can be used before we moved on to the next two functions. So first we import the home page object in our test, and then inside our test it becomes a lot cleaner. We can call homepage.albums and verify that the albums match the expected length. And inside the for each, we can call homepage.album to select the specific album by title. Not a lot of noise here anymore. Now let's look at our other page object functions. So the sort by function, it gets the select element with data test set to sort by. And of course, the search artist function similarly gets the input element with data test attribute set to search artist. So back in the sort test, we can use homepage.sortBy to get the select element and do the sorting. And inside of our helper, we can use homepage albums to get all the albums and then filter down by the index to verify it's the one we expect. In the search test, yet again, we can use homepage.searchArtist to find the input element, type our search query, and we can use homepage.albums yet again to get all the albums. So we've eliminated the noise and reduced the selector duplication in our test. And we're also telling a better story with these page objects. These page object function names, they carry more semantic meaning about the kinds of things a user would see and interact with on the page. So onto our third anti-pattern, and that's repetition in test. So let's use a simple example from what we just did to see what I mean. We'll see how the solution to repetition can be applied further in this talk to avoid other repetition as we go along. So let's return back to our home page object. Now this is a small page object, not a lot of functions, but you can imagine a page object with lots of more selectors. We already identified that the data test attribute selection syntax is verbose. We repeat it a lot through this test, including repeating some selectors like album list item. So we have lots of potential to forget a character or misspell something. Let's say we have some errors like this. We forget the M in album list item. We forget the opening quotation here. And we forget the closing square bracket here. So lots of potential for messing up because we have this really verbose syntax. So we can remove that repetition and dry things up by creating custom commands. Commands are functions like get and contains that we've already seen that are available on the CY object provided by Cypress. So we could replace the need to type out a data test selector every time with a custom command. So we can add commands with this cypress.commands.add method. And in this case, we're going to name this command getByDataTest. Then we can provide a function that will accept a key argument and then return the result of sci.get. We're going to use a JavaScript template literal here to interpolate that key and build the data test attribute selector within our command. Then we can import the commands in our Cypress support index file to ensure that these commands are available in all of our tests. So back in the homepage object, we can replace the manual data test attributes with the get_by_data_test command. Now we just need to provide the value of the attribute and not deal with all that messy syntax. Now we still need that syntax here for the sci.contains call, but we could replace that too. We can add a command called contains_by_data_test if we like, and that accepts the key and the expected content. And then we just pass those into sci.contains, again building the data test selector inside of the command. And then we can just simplify our page object function by calling contains_by_data_test. Now this is a simple example of some commands, but you can use them for anything that you might continuously repeat in your tests to reduce duplication. And we'll see some other examples, like I said, of custom commands in a bit. So the fourth anti-pattern is how we deal with API timeouts. Sometimes your UI tests can fail because the APIs they depend on may take longer than expected. So let's look at an example to see what I mean. Here we're testing the album page, which allows you to rate and review an album, a specific album page. So in this test, we just want to verify that the album, title, and artist match what we expect. So we know that Cypress is great about dealing with asynchronous things. That's one of the beautiful things about Cypress. So as the test runs, Cypress will keep checking until it finds this page object title selector. However, Cypress will eventually time out if it can't find the element. And the problem in this case is the page hasn't finished loading because the API is taking too long to respond. So Cypress's getters, they can take a timeout option we could use here to increase the timeout, but that kind of feels arbitrary, and we would have to do it for all of our selectors, which would just get really noisy again. So instead, we could wait for the page to load before even attempting to select any elements. And Cypress offers a wait command that is perfect for this. So let's say the API is taking around 5 seconds to respond. For safety, we could call this sci.wait function and pass in 6 seconds to wait 6 seconds before we try to match all of our elements. But this could still be flaky. The API could take longer than 6 seconds one run. Obviously, we need to address why the API is taking so long to respond, but how can we still ensure that the test passed for now? So we can introduce routes and aliases. Cypress lets you listen to API requests and do something about that without having to mock those requests out. So essentially, we're going to monitor API requests. So inside of a before each here, we can call sci.server, which signals that we want to start listening to requests. Then we can call sci.route to specify the route we want to listen to. Now I'm using a helper here from my own code base called build API URL, but it's building out the URL for fetching an individual album. And the asterisk here is just a wildcard for the ID of the album. So once I've given it the route, I can then use the as command to create an alias for this particular route that I'm listening to. And then back in my test, I can replace that arbitrary 6-second arguments with my route alias. Now, Cypress will monitor the album API, and then it will wait until it responds before proceeding with the rest of the test. So this ensures that the page is ready to be interacted with and inspected without creating test flakiness with arbitrary times that we would wait for. So the fifth anti-pattern is not testing your API. And this is especially important if you have customers that use your API in addition to your app. It's not enough to say your API is tested via your UI tests. Some of your API use cases may not match your UI test cases. There's lots of ways you could test your API, but if you want to test it end-to-end, why not leverage what you already have? We have this awesome tool called Cypress, and it can test APIs as well. So here we have a test that's going to fetch all the albums from a REST API. inside the test, we can use the request command from Cypress to make an HTTP request. We pass in an object with various options. So we provide the URL. We want to fetch all albums, again using my build API URL helper here. We can specify headers. In this case, we want to set the content type to application JSON. And then we can also even specify an auth bearer token, which isn't shown here, but that's coming from some test setup, my token. Now the request command handles asynchronicity just like any other Cypress command, like get and contains. So that means I can chain other commands off this HTTP request and do stuff with the data, make assertions. So I can use the its command here, which is going to grab the body property off the response, and then I can do further things on that body. So I could have a should assertion here, and I can verify that the body, which I expect to be an array of albums, matches the length of the albums from my test setup. And then I can use the each command, which if underneath the Cypress chain of commands we have an array, it'll loop over each item in the array. So for each album, I can then verify that the title of that album is a part of the expected album titles that I would expect to get back from my API. Inside another test, we could verify fetching an individual album. So again, we use the request command with URL, headers, and auth, just a different URL this time. And then we grab the body, and then we do another assertion. This time I'm using this contains subset, and just as an aside, that's coming from the Chai subset plugin. And then we verify that the properties we care about match what we expect without having to check every other property. So that's what's nice about this contains subset helper. So this is great. We can use Cypress's declarative commands to easily test our API. But we again are dealing with lots of duplication, having to type out sci.request with the same object every time we want to test an API. So we again can use custom commands here to remove that duplication. In this case, we can create an API request command, and then we can take the body, the URL, in an object, as well as any other options we might want. So we're going to pull those out into an options object via the object REST operator. And then we can get the token that we're going to need for HTTP requests, and we're going to talk a little bit more about this in a moment, but we'll get that from local storage. And then we're going to call sci.request. We're going to first pass in the object. We're going to spread out any of those additional options that might have been provided. Then we're going to build out the API URL, so we expect that the URL passed in was just the path. And then we're going to hard code the headers to have the content type of JSON. And then we'll assign the auth bearer token. And finally, down here, little tricky syntax, but what we're doing here is we're checking that if a body was provided, then we're going to use the object spread operator to spread in the body as a JSON string. So we can build off that and make other helpers commands like API get and API post, and they just call the API request command. So API get accepts the URL argument and just passes it into API request, as well as setting the method to get. Now in previous examples, method wasn't set, and that's because it'll just default to get. But here we're going to be explicit and say we expect the method to be get here. For API post, it's going to look a little similar. We'll accept the URL, and we'll accept a body. And then we're going to pass those along to the API request along with a method of post. So back in our test, we can simplify them a lot by just calling API get here. And so that reduced a lot of our code, and it's a lot clearer and easier to parse what's going on here. And for a more involved test, like this one that we haven't seen yet, where we want to test that we can review an album, and then we can remove the review from that album, we can use both our API get and API post commands. So we start off, we can use the API post to review the album. Notice we're passing in a URL and an object with the review we want to set it to. Then we can use API get to verify that that review persists. Afterward, we can use API post to remove the review, and then API get to verify that that review is no longer persisted. So this is really great, an easy way to test our APIs. And we can take that a step further. Because if we can test them in Cypress, there's no reason why we can't also test GraphQL APIs in Cypress. So we can leverage what we've already done for our REST API tests. So we could create a GraphQL command that accepts the query and it accepts any variables for that query. And we can pass those into the API post as the body argument along with our GraphQL URL path for the GraphQL API. And in a test, for example, where we want to fetch an album via a GraphQL API, we can build an album query that specifies the ID and the type of that ID because we need an ID to know which album to fetch. And then we can call our GraphQL command, pass in the query, and pass in an object that contains any variable values. In this case, we want the ID from our test album. And then we can use it to then drill down. We can get the response body, and then we can get the data property off the GraphQL response, and finally get the album filled. And then after that, we just have the same assertions before. We verify that this album from our GraphQL API matches what we had. So thanks to this request command, as well as custom commands, it's really easy to test your API, whether it's a REST API or a GraphQL API. So finally, for our last anti-pattern, I've hinted about this with the bearer token that we've seen earlier, but how do we handle app authentication in our tests? More importantly, how do we deal with a particular anti-pattern of authentication that we're going to see next? So more than likely, your app requires some authentication. Now that we've learned about the power of page objects and custom commands, you might be tempted to write a login command that logs in via a form like this in order to test your application. But the problem with this approach is that it adds unnecessary slowdown to your test. UI interactions, they're not super slow, but they're not super fast. And so this command could take 1 second almost to complete. So if you ran this command before every test, that's 1 extra second. It's all going to build up and drastically slow down your test suite. So unless you're actually testing the login page, you shouldn't be using the login form to log in other parts of your test. So instead, leverage your API again. Depending on your API interactions may only take 50 to 100 milliseconds. So it's a lot faster. So we can again create a login command. We can let it accept email and password arguments, and we'll use defaults for those from the cypress.env method. And this method here is just a great way to fetch environment variables from your Cypress JSON config file instead of hard coding them in your tests, in your code. We can call request. We can say it's a post request to the login URL and pass in the email and password in the body. And then we can grab the token off the body. In this case, I'm using a JWT. And so I'm going to set that to local storage because that's what my application expects. But if you're doing something different with sessions and cookies and whatnot, you can do something sort of similar here because these tests run in a browser where your app is running. So it can leverage whatever you're putting in, cookies or local storage. And then in your tests before each call, you can just call the login command before every test. So even if this isn't exactly how your app handles authentication, it at least gives you an idea of how you could leverage your API and some of these other tools to not bog down your tests by logging in through a form, but use your API. So let's recap the anti-patterns we've discussed along with their solutions. So the first two came from this Selector Syndrome. So depending on class names and tag names led to brittle tests. So we add attribute selectors. And those could get noisy though, and they don't necessarily tell a story. So for those, we can use data test attributes, as I said, and also page objects to clean up those tests to make them more maintainable and tell a better user story. For code that's repetitive and making tests noisy, we can create custom commands to dry up our code and encapsulate that logic in well-named helpers. When dealing with timeouts, adding arbitrary timeouts to selectors or arbitrary waits can create flaky tests, especially when APIs take long to respond. So instead, we can leverage routes and aliases to monitor and wait for those requests to finish. If we're not testing our APIs, that could be a huge gap in regression safety. So we can use sci.request and custom commands to be able to test REST APIs and GraphQL APIs. And finally, authenticating via the UI can increase the timeout of our test suite, and that could hold up automated builds. So we can instead log in via our API using local storage or cookies along with custom commands, as well as before each, so we can easily log in before test with greater speed. And that's all I have. So thank you for watching. I hope you learned some new advanced techniques to make your Cypress test suite cleaner and more maintainable. And there are links provided here for the slides and for the repo. Thank you.